Audrey here with the Leonardo and Leo at home. I am joined by Miss Rachel.
Hi!
And we have a really fun experiment today, but I want Rachel to tell us all about this crazy machine in front of us. What is going on here?
We are going to play around with something called Chladni plates. And it's named for the German scientist who actually took his time to run a violin bow down the side of plates. And he wanted to see what would happen and how they vibrated. It's kind of interesting.
That is really cool. I've never thought to do that, so I'm glad someone did.
He was studying energy, and energy moves in waves. And when we talk about waves, there's really two ways we can affect waves. And it's represented here on our box. We can play around with the amplitude and the frequency. Amplitude is how loud something is when we think about music, or how big the wave is. The frequency is how often it vibrates, or when we think about it in music, we think about pitch and tone.
Okay, so draw a wave here, and let me try to guess what type it is.
Okay, so we have a sound wave.
Okay, I think this one is going to be loud because this is very big.
Yes.
And I think it's going to be about even in tempo, or how fast it goes, because they seem pretty regular.
Yeah, waves usually tend to travel regularly, and it's a little bit more of a lower tone. I know that because it's a little more spread out. Our high frequencies tend to vibrate a lot faster because, like frequency, frequent flyer points, all of that good stuff, they vibrate at a faster rate.
So that would be very high pitched and super fast and not as loud.
Not as loud because it's smaller, absolutely. This actually gets represented on our Chladni plates, and it's really fun to play around with different frequencies because you get different patterns. Should we play around with them a little bit?
Absolutely.
All right, cool. So we're gonna turn our amplitude up. That means we're making our waves really big.
And I can see the plate starting to shake. It might be kind of hard for you guys to see, but it's just having a nice even shake to it right now.
Yeah, so what's happening is this motor underneath is vibrating at a certain frequency. This vibration is not in resonance with the plate. And now resonance is when an object is vibrating at the exact same time as whatever is stimulating it. So right now, the motor underneath is stimulating the plate. When they are in resonance, we get this really nice, loud sound, but we also get to see these really cool patterns because what is happening is the energy is actually traveling backwards. So it's originating in the middle of the plate, it's traveling to the end, but energy doesn't just stop at the end of the plates. What do you think happens?
I think because it has a stopping point, it comes back.
Yeah, typically it comes back towards the middle. So what we see is everything always has a vibration, but there's always going to be an equilibrium or a rest point. And that's usually in between the peaks and the valleys. And what's happening is, let's pretend like this is the end of our plate. The energy is actually meeting these waves and it's traveling back in the exact opposite pattern. And so where you see are all of these points right here, and we call these points nodes. And I learned this really fun fact. Nodes is short for no displacement. Now, the Chladni plate works best at higher frequencies, and that's how you get these really complex patterns because the high frequencies have smaller waves. So we're gonna turn our machine up. We're actually going to go ahead. Do you hear how it has this really special sound?
I do.
It's a little bit louder. That's because the plate is resonating at the same exact vibration with our motor. So let's see if we can find another point where it resonates. I'm going to turn it up a little bit more.
Yeah, can we make another pattern?
Let's find out. I'm going to add a little more sand to this side.
That's a different pattern than we've seen.
Yeah, this one's a little more complex because the waves are smaller.
And I see that it has peaks and valleys, and we even have a secondary one right there. That's where the sand wasn't moving.
Yes.
So that's the place of equilibrium.
Yeah, or no displacement.
I've learned already so much stuff today. This is
I know.
awesome.
This is kind of cool, right?
So I don't have one of these machines at home, and I don't think many other people are going to have it either. So how can I recreate this and take it back and show my husband and my kids and teach them about sound?
A really fun way you can do that is you can take a bowl and cover it with saran wrap and place it next to a speaker. And if you put something small like sprinkles or sand that we used, or Legos, anything, and watch to see at what point during that song the pieces are moving and vibrating.
That is so cool. So I need a bowl, saran wrap, and something light enough to kind of bounce with the speaker I have.
Yeah, absolutely.
That is so easy. I can totally do this, and I can kind of tell them about the different waves and things and have a little fun.
Totally. So if you want to see a bunch of different patterns, the Chladni plates can go up into really high frequencies and get really complex and actually incredibly beautiful. So this is something that you can actually look at a little bit more too if you wanted to research a little bit about him and his work.
I am so excited. Thank you so much for teaching me all about the science of sound.
Yeah.
And we will be back soon with you guys at Leo at Home, so stay tuned.
Thank you.